So thank you all very much for taking the time to be here today. Today what I'm going to focus on is the handover and the change part of the asset lifecycle information management model that Dick showed earlier. So first let me start. Let me find out which way I have to point this. Which way? Oh, hold it that way. That'll work. Did it go? Okay. So first let me tell you about our company, Areva. So Areva is the world's largest provider of nuclear-related engineering services and products. We cover the entire life cycle of the nuclear facility, from mining to manufacturing of heavy components to design and construction of nuclear power plants to the services and operations and maintenance and into the decommissioning and eventual dismantling of the plants. So I didn't say anything about power generation because we don't do that part. We're not a utility. We're a service provider and engineering provider for all those parts. But we don't only do nuclear, although it's what we're most known for. We also do everything related to non-CO2 emitting energy. So we're a French-based company, so if you've been to Europe very often, it's a huge thing to be able to say that, to be non-CO2 emission, and that's Areva's hallmark. We're carbon neutral in our operations. So we have some of the world's largest solar projects in our portfolio. Some of the world's largest offshore wind in Europe are part of our portfolio. We do biomass, mostly in a lot of places, and we also do fuel storage. So we have a big portfolio of activities. Our typical project in the nuclear side runs between 10 and 12 years of engineering and construction, and then we have between 60 to 80 to 100 years of operations afterwards before the dismantling. So our projects run a long time. So today what I want to talk to you about is our efforts to look about how we can achieve interoperability. The name on the slide is this product called AIR. It's a product we developed inside of Areva. I'll explain a bit more about that to you in a few minutes and show you it working. But the idea of AIR is to allow us to take all the data and to exchange it through a neutral format. So there are two methods of interoperability in the world. The first one is about what I call forced interoperability, and I don't mean it in a negative way when I say that, it's just a difference in terminology, where you do what John just described, and you put everybody into the same systems, and you force them to work in the same systems, and you ensure at the end of the day that all of your data is consistent. So it's a methodology, and there's nothing wrong with that. But across the life of our projects, tools change a lot. Over 100 years of lifetime, I hope all the vendors in the room survive 100 years, but I'm not trusting you to do that. Buy-ins, consolidations all occur, and maybe it'll last, maybe it won't. So we take a different approach. So in your traditional view today, you'll see a view like this, where you'll have lots of companies interengaging, lots of point-to-point connections in some cases, in a non-forced interoperability view, and you have to manage all of that. And sometimes you have the same people connected to the same vendor connected to 3 different suppliers in your project with different interfaces. So what do we want to do instead? So what our target is to eliminate the idea of point-to-point connections, instead use a neutral model in the middle that we can use for all eternity. And so today we're basing that off of ISO 15926. So if you're familiar with that standard, you know it's designed primarily for process industry. It's not exactly the same as BIM and IFC. The scopes are different, but in fact they're not so incompatible. But we use ISO 15926 as the central place where we want to say, I don't want to ever know or care which tools my partners use or my owner needs. I want to have something in the center that I can communicate with, but that I can manage and control. So that's the important part. So that's what we're going to talk about today. So Areva joined the FIATEC consortium back in 2011 as a way to become more educated. So if you don't know who FIATEC is, Ray will be glad to explain that to you in the back. And I think there's a presentation later today about another project that FIATEC does. But we joined FIATEC in 2011 in order to become more educated about what the current state of the art is around interoperability, to take advantage of all the experts in that consortium, to understand what our business case could be, and more importantly, what's practical to do. So we don't want to wait 25 years to do this. We need to do it on our projects today. So we took a real focus about what's practical to do. We also launched an internal project in 2011 to test for ourselves what, for Areva, the business cases could be, what the technologies could look like to support the business cases, and that's what we're going to look at a bit more in a few minutes. And then we've also launched, which is exactly the point we're going to talk about today, some external cases to test the feasibility of interoperability. So it's nice to have a theory, it's nice to have R&D, but at the end of the day you have to prove it works. And so that's what we're going to look at. So what are we looking for in this? So from a business context, there are 3 major points we'll talk about, but it's not all inclusive. The first one is to improve our ability to define data handover. So if you go, I don't know how it is for all the companies or all the industries, but when I go to a potential client and they say, I want you to hand over the data, I say, which data? They say, all of it. That doesn't really help me very much because all of it doesn't define which part's mine, which part's a supplier, which part is another person's. So to define, and it doesn't also doesn't define how and when and in what format. So we try to look and say, how can we use interoperability to solve that question? The second one is about reducing the cost of non-quality. So today in a lot of processes, if you allow a non-single source of tools to be used, you have to worry about copying from Excel to another file or moving from your design tools into your operation and maintenance systems. And sometimes there's a lot of cost of non-quality. NIST did a study several years ago that showed billions of dollars are lost in the US each year as a result of data exchange problems on large projects. So we're trying to solve that. And then the third one is allowing us to improve our lifecycle management of the asset. As I said, we run plants. We run our internal plants for recycling for 60 to 80 years. We run plants, our customers run their plants for 60 to 80 years. They're going to ask us to do services. We're going to offer them new upgrades. We're going to do work together. We want to be sure that across the entire life cycle, only the short construction phase, but into the long life cycle, that we can manage the data effectively. And we want interoperability to help us do that. So is there a real return on investment? So I'm going to see if we can get this video to run. I'm going to try to show you one sample of that. So for us, we look a lot about tool obsolescence. What happens over 10 years of a construction project if your tools go out? So we did a test internally to Areva to see if can we really use interoperability to do that. So we started with an AutoCAD P&ID in our existing design tools. We used our Areva platform to convert that to ISO 15926. And it should be, if I'm on timing right, it should be drawing the intelligent part of the drawing. So what you see there now is it's creating the intelligent structure from the old P&ID into a new design tool. So without any manual intervention, we just push the button and go. This is a faster video. It takes about 2.5 minutes to do the entire process. So now you'll see that we're going to import the drawing. We're actually going to import two versions of the drawing. We're going to import the ISO 15926 drawing so we can see what it's supposed to look like in ISO 15926. And then we're going to view the actual drawing that we'll produce and generate and send to someone else. And then at the end of the video here, we're going to, hopefully in about 2 seconds, I'm talking faster than the video today, we can see the comparison of the two. So without manual redrawing, we actually capture about 85% of perfection. And the reason we don't catch the 15% is because the people cheated on the original drawing. And they didn't connect necessarily the pipe to the pump or whatever, and we don't fix that automatically. We make the engineers do their job. But where we can automate it, we've done that. So, oh, sorry, let me go back. I went too fast. So does it save us any money? So on our typical nuclear power project, a large project, we have about 1,000 P&IDs on each project. So for the 1,000 P&IDs, we calculated the cost to migrate. We're in the middle of it right now, as a matter of fact, having to move from one tool to another in the middle of a project. And it takes us, we calculated that using air to do that, this process is so it will save us about $400,000 on just that one migration. So that's a significant savings. So that's important. So how about external? So we just talked about this a couple minutes ago. So the first lesson I'll tell you is don't agree to data handover until everybody agrees on what data handover means. So I'll tell you today that we're working on a project that perhaps we were a little bit naive on. I'll just be honest about that. Well, we agreed with our client that we would do data handover at the end of the project. But we never defined what it meant. And what do you know? Their idea of what data handover means and what ours mean don't match. And so we've spent almost $1 million so far to do nothing except agree on data handover. So there's $1 million we've spent, which neither one of us needed to do, to agree on what data handover means. So what we want to do now is to say, can we completely change that philosophy and now say, here's our natural offering for data handover. Here's the data we can provide. Here's the methodology we'll use, the timing, the format, the quality, the consistency, the requirements management configuration, all those aspects that are required. Here's how we propose to do it. What do you think? To completely change the ball game for us. So, as I said, we have to prove it works. And so that brings me to the external collaboration we did with Bentley. So we asked Bentley last year to help us to prove data handover between the Areva systems and an external system without actually ever making a physical connection between the two of them. So we chose Bentley for two reasons. First of all, they're very aggressive in the idea of interoperability, and so it was a very logical fit for us. The second one is, to be honest, we don't use their products. So it was a really important point, because what we wanted to prove is not that we could connect to our own internal systems, but we didn't really care what systems our owner-operator used, we could connect to them. And the third point is that EB, if you're familiar with the nuclear industry, now the ASAWISE tool in Bentley's portfolio, is very well used in the nuclear industry in the United States as a operation and maintenance backbone. So a lot of utilities use that. Some of them even use it for safety qualification databases. So it was a logical thing in our nuclear environment to ask Bentley to support us, and we thank them for that. So here's what we did. So I'm going to walk you through parts. So the way this will work is we'll take a look first at the in-between point. Don't run the video yet, but we're going to run that in 1 second. I'll point for a second, apologize for that. So what we assume is that our system connects to air. So we have our interoperability platform. And in the ideal case, our partner, in this case Bentley, has theirs. And they have their interoperability platform. So in the ideal world, I don't care what this is. I just care that it's ISO 15926 compliant. So in the reality of the test, we had a small problem. And one of the connectors didn't work correctly, so we built an air one just to make the demonstration work. In the real world, we could do that, and we will help our partners and customers and owners to do that if necessary, but it's not really what we don't have to do it. So the first step, however, is to make sure that you're talking the same language. The ISO 15926 is the same. So if you run the first video up on the left there, I'll show you what that looks like. Okay, so what we're going to do is the fact is we've agreed now on what data handover means. What data do we have to transmit to each other? So now we have to be both sure we're both mapped to the standard so that the standard can do the workforce of exchange. So what you should be seeing on the screen here is, in fact, we're not. So we have the ability to check our data model against the standard to see are we matched, are we complete or not. This particular case, the room, which is what we're going to focus on now in the thing, we don't have a complete mapping for that. So we can see that. So now we have two options. We can go do the work ourselves, and we can build a mapping, and then check at the end that we match our partner. Or we can be smarter about it, and if our partner's ahead of us, we'll just use theirs. So that's what we're going to show. So now inside of our AIR platform, we have the ability, with permission from our partner, to query their RDL, to query their library of information. And that allows us then to save all the time of mapping. So in this case, we're going to look and we're going to say, okay, Bentley has an RDL, it's already running, it's already existing. For this room, what do they use? And you'll see in this video that, in fact, they're using the official ISO mapping, so we like that, so we're going to choose to use their definition. So we do that. Then, how far, am I ahead or behind? Where is he at in the video? Okay. So he does that. So now we've mapped, and now we're mapped to the same basic library. So now what we're going to do is take a second look, and there's an important point here I want to point out to you. We're going to look at the MTO area, which is a set of attributes. We're going to also see what Bentley used for that. But notice that in the fact that in that video, the names weren't the same. So what Bentley had named the MTO area was different than what I did. But in fact, I don't care, because it's not important that my name and his name matches. It matters that the middle matches. So we have the ability to query that, see that, and immediately use that. And that's a lot faster methodology as we mature more and more with partners to get to this idea. All right, part two. So now we need to move data. So what we're going to do first is we move it, not yet. That's okay, we'll do it, we'll come back, that's okay. So first we'll move data this way. We'll move it from AIR into EB, and then we're going to go back out. So what we're going to focus on now is the EB part. So I'm going to focus on one part just for the demonstration. So you can go ahead and run it now, that's fine. So what we're going to do first is we're going to retrieve ISO 15926 data from a partner into EB. So what we've done is we've already created here in the facade, this is for those of you who are techno geeks, which I'm not, this is an RDF OWL-based facade or something like that. You have to check the numbers, which allows us to make our data available in a secure, cybersecurity controlled methodology available to partners. So we've done that, we've made it available from Areva. Now EB has checked it in. In fact, they have nothing in their database. So now what we're going to do is let them query that data on the ISO 15926 facade. They'll be able to see that, in fact, this is the data that exists. Important point, they can see if it's new, in other words, it doesn't exist today, if it needs to be updated, and they can choose to update it or not, or if it's no change so they don't have to mess with it. So it allows us to exchange the data with control to know what's changed. In this case, they're going to import this value into EB. Again, facilitated by the fact that we've already commonly mapped, so we know that they know how their data model matches up to the information, and voila, it's there. So now we can import that. All right, so now step 2. We want to publish it out and make it available. So I want to show you quickly how that works, because what we asked to do in the scenario was now for Bentley to make changes to the data so we could simulate the fact that the owner might change a requirement or a value or a design input, and we need to check it. So what they're going to do is we look inside the facade from Bentley, not the same facade we looked at before, a different one from Bentley. It's empty. So there is no data available for us to retrieve on the Areva side. So now what we're doing inside of AIR is we're retrieving the data from the EB server. We're collecting that data into an XML file, which should run just in a second, I think. No, maybe we already did it. Maybe it's faster than me. So, and then what we do is we take the XML file and we publish that to an RDL. In this case, again, controlled by security on who can see it. You have to deliver to your client the security rules and the URL. Not everybody can query it and find it. It's not Google. So you have to be able to do that. And then we do that. So all that information occurs. We share that out. And then we go back over and query the same repository. And now we have all the data available for Areva to retrieve and pull back into our systems. So that's the way we see for it to work. So what are some lessons we've learned in the process? The first one is that I gave you the highlight view, but if you go to any technical meetings, it gets really, really deep. Understanding interoperability and how to make it work is not easy. It's really easy to get lost in all the terminology. I always say there's a real difficulty in getting the people who understand how to make it work and the people who will pay for it on the same page. It's not an easy thing to do, but it can be done. The second point is that your methods have to consider a time horizon. So today, depending upon what you want to do, as I said before, I take a practical approach, not the perfect world approach. So today I can move 2D, I can move PNID to PNID for several cases. I can move 1D information, but I can't do 3D yet with ISO 15926. So I can't move from one vendor to another or even subsets of that. Not yet. So what you have to look at and say is, okay, what are my immediate business needs? What are my next term business needs? And what are my long-term business needs? And build a plan that will allow you to get there. So in our particular case, 1D and 2D, we feel pretty confident about, where we're doing an R&D project this year to evaluate what our short-term and mid-term roadmap will be with 3D. And in fact, we may decide to use a combination of standards to do that. We may decide to take part of IFC, because it has a very mature model we can use, combine that with some elements of ISO 15926 to exchange 3D data. First focus will be on catalog information, because it's the most difficult, most important for us. The next point is that there are industrial solutions coming. So you see more and more across the world. Since I happen to live overseas, I get to participate in a lot of overseas forums too. A lot of places where they're working on now industrial solutions to facilitate interoperability. Now, the AIR platform was designed to be standard neutral. And what I mean by that is, today we're focusing on ISO 15926, but the technology doesn't care. We can easily incorporate IFC, AEX, or another standard. The intent is that we don't, to use a Lord of the Rings analogy, I'm not looking for one ring to rule them all. I want all the rings to work together. So that's what we're focusing on from a practical standpoint. An important point, which exactly mirrors what John said before, is doing interoperability requires commitment. If you think you were going to, let's say 2 points about that. If you're waiting on interoperability to happen, you're going to be waiting a very long time, because it does not going to happen without your own engagement. So if you want to be interoperable, you have to commit to doing interoperability. And you have to commit in advance. So our current, I said already, we've been working since 2011 on this activity. And in fact, we will finish our first real phase to tell the world that we believe we're ready to go, maybe even into commercial operation at the end of next year. So we're building a technology that makes a difference. But either way, you have to take commitment to do interoperability. Being interoperable, that's a hard thing to say, requires collaboration. So if you go out and build your own interoperability solution, it would be really nice for you, but it's no guarantee to work with anybody else's. So it's really important that if you're going to try to pursue interoperability like in this manner, that you engage in organizations that are trying to facilitate that you find other people who are to help you, so that you're not interoperable by yourself. It's our opinion, however, for effective asset lifecycle management, interoperability is mandatory. It's not optional, it's mandatory. You have to choose which method you use, and that's fine. But you can't ignore the problem. For the modern today, with data-centric type of plants in 100 years for a nuclear power plant, we can't afford not to have interoperability. We have to have it. But you have to evaluate your business strategies. The business strategy for Areva is not the same as the business strategy for everybody else. You have to evaluate your own business strategies. You have to look for what ROI you're expecting, and you have to be realistic. You have to pick your quick wins, you have to pick your long-term commitments, and you have to find a way to do that. But the challenge I will leave you with is, can we afford not to? Originally it said, can you afford not to? But I realized that wasn't very collaborative. So can we afford not to? So in fact, I would tell you that I believe the answer is no, we can't. We have to find a way to solve this issue, and we're taking one attack to try to do that. Okay, so that was really fast. I hope that was not too fast. But I left my contact information on there. If you have a question, I'll be more than happy to share it. Thank you very much.